This is the third part, talking about why the Audiolab 8000S could be something of your interest as a collector item, something maybe to have like a secondary amplifier, a secondary hi-fi set in your setups. Now I wanted to mention that this is a revision 4. We will be touching in the next video about that the capacitors suggests to me that maybe this was part built in UK, and around that time it was acquired by the AAG group and finished possibly in Asia. In this video we have been talking about, in the previous video we have been talking a little bit about the ventilation problem. There is where I was breaking that video. Now I wanted to mention in this continuation the heat. I've mentioned that all the heat that is being generated inside has no way to go out. That makes that the amplifier is always warm to the touch. And it's no surprise. If you look at this is a heatsink, another heatsink, another 4 heatsinks here. This is another heatsink over here. I think there is another one here on the right that you cannot see in the video. Another heatsink here. This is a heatsink screwed to the side with 2 transistors screwed on the block itself. And then there are more small transistors. These things are also having an aluminum block as heatsinks. So this is an amplifier that is consuming one hell of a lot of current. You can already imagine from the size of the toroidal transformer and from the side of the capacitors. It has a lot of power. It apparently, from what I've read on the internet, it wasn't designed to have so much power. So there is a weak point here that we will discuss in the circuitry topic or video. And look at those huge transistors, 4 in total, connected to the heatsink. So yes, this will use that chimney effect that I was talking in the previous video. But a lot of the heat will also dissipate inside, and it will have no place because look, the heatsink is covered. So it creates a perfect chimney effect, but that also makes it more difficult for the heat inside to piggyback on the heatsink to also dissipate that heat. More things of interest to discuss about this amplifier. The binding posts. You will see that the binding posts are multiple, but they are not for 2 sets of speakers like other amplifiers of that era. That is because this amplifier, although its price was not that high, it was already supporting B-wiring. B-wiring was something that started to get some attention around that time and was normally done by having multiple amplifiers, maybe a preamplifier with multiple power amplifiers. So yeah, it's on a print board. I hope you can see it there in the camera. And then the cables run into the circuit board. I prefer normally when the cables go straight, are straight soldered into the binding posts. But I guess that it was a way for handling the B-wiring, that this was an arrangement that was working out better for the engineers. As I mentioned in the previous video, a power amp in, pre-outs out, no bridges like in other Japanese amplifier. The bridging is done by the mode selector, which is that one. Here you see on the camera also the input selector with a motor, the volume with a motor, and then the rec selector and the mode selectors are manually driven. The range of inputs, outputs, there is this space in between, not sure why, and then the grounding screw that I mentioned in the previous video. Now look that the front fascia also has a metal chassis. I don't know if you can see it in the video, otherwise try to do a zoom. And you will see again a metal chassis that stands apart from the aluminum front fascia. Again, that all together gives it that rigidity. Actually, I can hardly bend this thing from the corners. While if I had another amplifier built similarly with a top cover and a bottom cover and you take them off, it will be very flimsy overall.